Don't forget to subscribe and ring that bell.
Hey, welcome back. We are going to continue the Algebra 2 Cliff Notes, or the summary of the Algebra 2 course right now, and we are going to start with factoring. Factoring never goes away. I say this in all my classes, and it is true. It is true. And we always start by taking out a GCF if we can. All right, I want to take out a greatest common factor. So I'm looking at this. I need the greatest common factor between my numbers, 6 and 9. That will be a 3. And the greatest common factor between my variables is always the smallest exponent. You notice that I have a 2 with this n, and this is a 1. Okay, so it's always the smaller exponent, n to the power of 1. This is my GCF, okay? I need to divide that out of both terms. And what I have left, okay, 2n plus 3, okay? This is factor, but don't forget, my GCF, I always need to write that out front. And there you go. Factored completely. There's nothing more I can factor out of this parenthesis. My all-time favorite factoring, the product sum method. All right? I need to find two numbers that multiply to my C value. That's this. So it's going to multiply to my back number. And it's also going to add to my B value, which is the middle one, 14. However, I want to have 1 x squared. I want it to be, the x squared has to be alone. I don't want this negative here, okay? I want it to be a positive x squared because that is going to make life worth living and easier. So what I'm going to do is I'm going to take out a GCF of -1, okay? I'm going to take a -1 out of everything. So if I divide everything by -1, I'm really just flipping the sign, okay? This won't happen a lot. I just threw it in here in the event you see it. But that means I'd have a positive x squared minus 14x minus 32. Okay? What we see right here is more common for factoring like that without taking that negative out. But we took the negative out. Now, two numbers that multiply to be -32 that add to be a positive 14. Okay? We're using x's. And I know that is going to be -16 and +2. If I combine them, I get a -14. And if I multiply them, I get a -32. I'm talking about these numbers right here. And don't forget, my GCF should be right out front. And we are done. There you go. Oh, the number of times someone can't recognize this. It's crazy. Adopts. It is a difference of perfect squares. That's where this DOPS comes from. Okay? So, what is it? I have two perfect squares here, but notice the word difference. That means subtraction, children. I can only do this if there's a minus sign between these. If there is a plus, if this was x squared plus 9, I cannot factor it. That's why it is called a difference of perfect squares. And how do I do this? I just take the square root of each. Right? The square root of x squared, well, that's just x. Square root of 9, that's 3. And I have two sets of parentheses. Both have an x and a 3 in them. One is a plus, one is a minus. That's it. I could have written the minus first. That's fine. Okay, could write it like that. It doesn't matter, one way or the other. That's how it works. I'll put the plus first here. Done. Next one. Okay. Same rules. These are both perfect squares, and they're both being subtracted. Okay. The square root of 25 is 5. The square root of x squared is x. Since this is in front, I'm going to put this in front in both parentheses. Okay. The square root of 49 is 7. Since my 49 is in the back, I'm going to put the 7s in the back. One is a plus and one is a minus. I'll start with the minus, then the plus. It don't matter. We're done. This stuff is kind of easy if you recognize it. Slip and slide. Slip means I multiply. Slide means I divide. All right. What is this method here? Now, some people do a guess and check. Some people do an M method. I like slip and slide. How come? Because slip and slide always brings me back to the product sum form of factoring, which was this right here, which I think is easy. Okay? So, how does this work? If I can't take a GCF out of here, okay, there is no common factor between 4 and 3 because 3 is a prime number, okay? Notice there's a G here, there's a G here, but there's not a G in this term. So I can't even take out a G. So what do? I slip the 4 to the back by multiplying it by my back number. That's what I do, I multiply. So this goes bye-bye. I have G squared minus 4G minus 3 times 4 is 12. All right? Now I'm back to that product sum method. And this is what I like about this. If I cannot factor this, if I can't factor at this point, then my polynomial or my expression is unfactorable. Okay? If I can't factor at this point, it's unfactorable. I only had to do one thing. I had to just do a quick little multiplication to check to see if that's factorable or not. But for our sake, this is factorable. Okay? Two numbers that multiply to negative 12 that add to negative 4. I have my G's. Okay? And it's a negative 6 and a positive 2. Both of those multiply to negative 12 and add to negative 4. However, this isn't just called slip. This is called slip and slide. Okay, I can't just leave it like this because remember this 4 that I had out back, I multiplied? I've got to undo that multiplication. But now I have 2 backs here. So I'm going to undo that by dividing both of those by the same number I multiplied by. Okay, here's the slide and the divide thing. Okay, I got to simplify these if I can. Both of these fractions will simplify. G minus that turns into 3 over 2. My 6 over 4. And this plus 2 over 4, well, that's 1/2. So the last step, okay, we slipped by multiplying. We slipped that 4 to the back and multiplied. We slide by dividing to both backs. Now there's something I call bottoms up. Bottoms up, bottoms up, up. And what happens is, if these fractions don't reduce to a whole number, sometimes they're a whole number and it's fine. If it's a fraction, the bottom comes up to the front here. So that's 2G minus 3. And this is 2G plus 1. Okay, and if I had to solve these, I can set them both equal to 0. But they just asked me to factor, and there you go. So in review, I slip, and I end up with this. If this is unfactorable, I don't do any more work. But it was factorable. I got here in red. Okay? I bring the number 4 back in to slide, reduce, and bottoms up. And there you go. Perfect. If I have more than 3 terms, if I have 4 terms, I'm going to factor by grouping. What do I mean? I'm going to group the first 2 terms together, and I'm going to group the second 2 terms together. And I'm going to factor a GCF out of each one. I'm looking at the first term, and I can only take out an x squared, right? Remember, it's the smallest exponent. So if I take out an x squared, if I divide both by x squared, I end up with 3x plus 2. Now, the whole point is, when I take a GCF out of the red, I want the same thing to end up in the parentheses. I want positive 3x and positive 2. And I do that by dividing both by a negative 9. That's my GCF. Okay? And now it's the point where I just copy. I know some of you are good at doing that. Yeah. My x squared and my negative 9 go in one parenthesis together. Okay? They go in one parenthesis together, both of those GCFs. This just gets written once. I don't have to write it twice. There you go. This is factored, but it is not factored completely. How come? I made a note saying that sometimes people don't recognize adopts. This right here is a difference of perfect squares. Okay. In fact, that's one of the differences of perfect squares we actually did. Okay. So I know that right here, this is going to turn into x plus 3 and x minus 3. And then I just carry this along for the ride. This is factored completely. As if there weren't enough factoring methods. This doesn't factor, but it solves for us. Okay? This is called completing the square. Now, we should still try and take out a GCF first, which I notice we can do right here. I'm going to divide both sides by 2. Okay? What I do to one side, I can do to the other. Okay? 2 goes into 2, that cancels, and I just have x squared plus 2 goes into 4 twice, it's 2x. And 2 goes into 10 5 times, that's minus 5. 0 divided by 2 is still 0. That's good. All right? So we did our GCF, check. The next thing is, I'm going to move the constant. That's the number without the variable. I'm going to move that to the right side or the other side of the equal sign. So I just want, okay, on one side, all the terms that have my variables, and on the other side, the terms that don't. Now, this here is the process for completing the square. This is the brain trust, the child, the meat and taters. I got to take my b value. Okay, in this case, my b value is the number in front of the x. So I got to take my 2. All right? And I've got to divide it by 2, then I got to square it. So I take my number 2, which is my b value. I divide it by 2, and I square it. And most of you can just say, oh, well, that's going to be 1 squared, which is 1. But what I want you to do, what I tell my students is, I want you to simplify what's in this fraction first. 2 divided by 2 is 1 squared, and 1 squared is 1. Why do I want you to do this? Because this number will come back into play in a moment. All right? The first thing that I get from that number is the following. All right? After I do that process, I got to add that to both sides of my equation. So this number here that I get, I got to add to both sides. So I'm going to add 1 and add 1. So I've got x squared plus 2x plus 1 equals 6. So, right, what comes next? Now I got to factor the left side and write it as a binomial squared. Meaning, I can find 2 numbers that multiply here, that add here, whatever. But you know what? I don't even have to know how to factor. This is now a perfect square. That's why, okay, the left side is a perfect square. The right side will stay the same. That's why this whole process is called completing the square. You just made a perfect square on this side. It's x, and there's some number here. Guess what? Whatever number is here in the parentheses, isn't that a positive 1? Gets put in the parentheses here. You don't even need to know how to factor. All right? So now, okay, I just did step 3. Now I just take the square root and then I simplify this. Right? I just get x alone. Okay, I'm on the last step. Take the square root of both sides, and don't forget, all right, square roots and squares cancel, so I have x plus 1. You can say the square root of 6, but don't forget, whenever you undo a square, the result should be a positive and negative. All right? And last but not least, we'll do this in some sort of cool blue. When it says solve for the variable, there's really just one more step left. We're just going to subtract 1 from both sides. So x equals a negative 1 plus or minus the square root of 6. Woo! It's not a horrible process, but the whole point behind it is this number 2. Okay, this whole point behind here is this process right here. Okay, because not only does it complete the square for you, but it also tells you what goes in that square. I mean, so again, not horrible. Okay, I'm not going to do a problem out like this because I think this is on your reference sheet as of right now. That might change in the future. But if a quadratic formula, if you have something, some number in front of x squared, some number in front of your x, and some other number here, and you can't factor it to solve, you can use the quadratic formula. What do I mean? Well, we'll color coordinate this. Okay, the quadratic formula is, okay, and this will solve. This is x equals this whole thing. I take my b value, and I have to negate it first. Plus or minus the square root of b squared minus 4 times a times c. Now that is all under the square root, the b squared minus 4ac. Okay, all over 2 times a. All right, and that will give you your answers. Okay, you get 2 of them because it's a plus and minus, notice. If you don't have to show your work, I hope you know whatever this is with your numbers in here for A, B, and C. I hope you know that you can graph it. And the x-intercepts, which we call the zeros, are also the solutions, are also what your x equals. Okay? The discriminants, you know, FYI, when we talk about the quadratic formula, notice the part that's underneath the square root here. Okay? This is the part right, it's b squared minus 4ac. That part without the square root, that's what we lovingly call the discriminant. Okay? So I am looking at this right here. Forget the square root, it's just that thing. If I take my numbers, okay, I'm going to make something up right now. Y equals negative 3x squared plus 7x plus 2. Okay, and I'm looking at this. I clearly see that my A is negative 3. My B is 7. And my C is 2. All right, I can use those numbers and put them in here. So if I have B squared, I have 7 squared, right? That goes in for the B, minus 4 times my A, which is negative 3, okay, times my C, which is 2. All right, so I've got 49 minus, okay, well, minus 4 times minus 3 is a positive 12, times 2 is 24. So 49 plus 24, and that gives us, oh my God, 73. That's what I get. And if you want to check that, I mean, you have this calculator the whole entire time. If you are ever unsure, and I would hate to make a boo-boo now at this point, we have 7 squared minus 4 times negative 3 times 2. 73. We're good to go. Based on this number right here, I can describe the roots. Okay? Okay. If this is bigger than 0 or positive, which is what I have, and it's a perfect square, then I have 2 real rational roots. if this is bigger than 0, which is what I have, and it's not a perfect square, then I have 2 real irrational roots. If it happens to equal 0, then I have 1 real root. Or sometimes they say you have 2 identical or 2 of the same roots. And if it happens to be less than 0 or negative, then I have imaginary roots. So for my purpose, they are both, okay, it's one of these two because it's bigger than 0. So either I have a perfect square or 73 is not a perfect square. Perfect squares, I do that by PS. That's 1, 4, 9, 16. How come? Because this is 1 squared. This is 2 squared. This is 3 squared. That means if I take the square root of it, I get a perfect number, 1 or 2 or 3. 73 is not a perfect square. So it's not this one. It is not a perfect square. So I have 2 real irrational roots. 2 real irrational roots for the original problem we started with up here. So if I were to graph this, my x-intercepts are zeros, they wouldn't be nice numbers like at 3 and 2 or 7. It would be 1.8. It'd be some run-on decimal, some irrational number. And there you go. I think this will be our last one we go over for this video before I start part 3. All right? System of 2 equations. This can be done algebraically or graphically. I'm going to show you both. I'm going to show you algebraically because this might be a part 2 question, okay, or short answer question, where you need to know how to do it algebraically. But then we're going to check that answer in the graphing calculator. How come? Because if this was a multiple choice question, do it in the calculator, graph it. Don't do all that work. Anyways, if I were to graph this, I want them both to be y equals. This is already y equals, okay? But I want to change this one so that it's y equals. So what I'm going to do is I'm going to add x to both sides. So y is going to equal x plus 4. So the 2 equations I have when I have to graph them, y equals x plus 4, and y equals negative x squared plus 2x plus 10. But before we graph them, let's do this algebraically, and we still needed to do this. So what I'm going to do is, if y equals x plus 4, then I'm going to substitute in for this y, x plus 4. So we had y equals, okay, negative x squared plus 2x plus 10. But in for this y, I'm going to put x plus 4 equals negative x squared plus 2x plus 10. How come I want to do this? Well, if I'm going to solve for a variable, I need to have one variable. By substituting an x plus 4 in for y, I don't have a y and an x anymore. I only have an x. So what I'm going to do is I recognize that I have an x squared, I have an x, I have a number without an x. This is going to be a quadratic. So I'm going to take everything on the right and move it to the left. How come? Because I like it when my x squared is positive. It's always easier to solve. I'm going to subtract 2x, and then I'm going to subtract 10. And on the right side, everything goes bye-bye. I have x squared. 1x minus 2x is negative 1x. And 4 minus 10 is negative 6. I now have a great product sum. 2 things that multiply to negative 6 that add, that's a negative 1x, people. So 2 numbers, okay, that multiply to negative 6, that when I combine them are negative 1, are negative 3 and positive 2. Okay, they multiply to negative 6, these 2 numbers, and they combine to negative 1. Good to go. I need to solve for these now. If x plus 2 equals 0, I subtract 2 from both sides, and x equals negative 2. I do the same thing on this side. X minus 3 equals 0, and I add 3 to both sides. So x equals 3. I am not done. If you leave this as is, two things. One, you did really good work. You got your x's. But I'm trying to find my x's and y's. If I graph these, they're going to intersect at a coordinate. I need two coordinates. Okay, I need an x and a y for one coordinate. I need an x and a y for another. I found both my x's. Okay, 3 and -2 are the x coordinates that are going to go here. Okay, so x is 3 and x is -2. I need to find the y values for each one of those coordinates. How do I do that? Looky, looky. Y equals x plus 4. So I have an x that's equal to 3, and I have an x that's -2. Don't I? I do. So let's plug this in. Y equals x plus 4. Okay, well, 3 and 4 is 7. So when my x is 3, my y is 7. There you go. I found one of the coordinates. I'm just going to do the same thing for -2. Y equals my x value, which is -2, plus 4. If I take -2 and add 4, that gives me a +2. When my x is -2, my y is +2. There you go. Now, that was algebra. It was a bit of algebra. I'm going to show you how to do it graphically. If this was a multiple choice problem, my goodness, why would you ever do all that work? Remember, I want to graph. Okay, I want to graph. What happened there? Oh, I know what happened. I want to graph this y, okay, with a -x and everything. And I also want to graph this y, which is x plus 4. So I'm going to turn my calculator on. Going to go to y equals. And the first equation is -x squared plus 2x plus 10. And the next equation is just x plus 4. They need to be y equals. Okay? And when I graph these, remember, we have two answers. It should be 3, 7, and -2, +2. So if I graph these, here comes the first one. It's a parabola that opens down. And here comes our x plus 4. Oh, look at you go. The little engine that could. Now, I could look at the table, but I am just going to hit second trace and use these intersect function. That was weird. The intersect function. So all I've got to do is move my little spider dude. You see it kind of flashing up here. I'm just going to move it to the left. And I just got to be close. I don't have to be right on it. You see how there's 2? Whatever one he's closer to, it's going to give me. So I hit enter 3 times. That should be -2, +2. And there you go. You'll see at the bottom, -2 is x, y is +2. Good. To do the next one, I can't just move there. I got to go second, trace, and pick the 0 again. And now I'm going to move all the way to my other intersection point. I just got to be close. I don't have to be right on it. Oh, right there. 1, 2, 3. Oh, check for, did I pick a 0? Oh, I'm a terrible person. I picked the 0. I picked choice 2. I didn't pick the intersect function. All right, there you go. 1, 2, 3. And that's 3, 7. Perfect. So there we go. We have our, and this is great. I love it. We have our 3, 7 and our -2, 2. We are done with part 2 of the Cliff Notes for this course. Hopefully, I'll see you for part 3. Bye-bye.
Don't forget to subscribe and ring that bell.